Morning students, continuing with our chapter number 3, matter. Today we will study the effects of heat on matter. First effect is expansion. Almost all forms of matter expand on heating and they contract on cooling. On heating, the particles of the substance gain energy and start vibrating rapidly about their positions. They are pushed away from each other, due to which the intermolecular space between them increases. As a result, the size of the substance also increases. The increase of size of matter is called expansion. And when the expansion takes place because of heat, then it is called the thermal expansion. On expansion, the basic properties of matter also get affected. That is, its shape and volume gets changed. Most solids expand on heating and contract on cooling. However, different solids expand to different extents for the same rise in temperature. A liquid expands more than a solid, and a gas expands the most on heating. Almost all the states of matter expand. However, water is one such substance which expands on freezing. That is why the ice occupies more space than water. We will do an activity to demonstrate the thermal expansion in solids. For this, the materials required are Bunsen burner, a beaker with cold water, a metal ball and a ring apparatus. The procedure followed is we set up the ball and the ring apparatus as shown in the figure. Notice that the metal ball can easily go through the ring attached to the stand at the room temperature. Now turn on the Bunsen burner and heat the ball over it for few minutes. Try it to pass this heated ball through the ring again. We will observe that the ball does not pass through the ring as it has expanded on heating. Now we will put the heated ball in the beaker containing cold water. Again we will try to pass the ball through the ring. We will observe that this time the ball passes through the ring as it has contracted on cooling. So we conclude that the solids expand on heating and contract on cooling. We will do one more activity to demonstrate the expansion in liquids. For this, the materials required are a round bottom flask, a capillary tube, single holed rubber cork, tripod stand, water, wire gauze and a Bunsen burner. The procedure followed is we fill the round bottom flask with water up to its brim and close its mouth with a single holed rubber cork. Insert the capillary tube into the flask through the rubber cork such that some water from the flask gets into the capillary tube and reaches a certain level. Now keep the flask on the wire gauze and heat the water. We will observe that as the water in the flask gets heated, it expands and the level of the water in the capillary rises. Now we stop heating the water and let it cool for some time. We will again observe that the level of water goes down as the water in the flask starts cooling. We conclude that the liquids expand on heating and contract on cooling. Do another activity to demonstrate the expansion in gases. For this, the materials required are a test tube holder, a capillary tube, a single holed rubber, colored water and a burner. We take an empty test tube and close its mouth with a single holed rubber cork. Take a capillary tube in which small amount of color water is trapped. We observe the level of colored water in it. Now we insert the capillary tube in the test tube through the single holed rubber cork. We hold the test tube with the test tube holder and heat it over a burner. We observe that the color water rises up in the capillary as the air in the test tube expands and pushes the colored water up. Now we stop the heating of the test tube and let it cool for some time. We will observe that the colored water comes down to its original level in the capillary tube as the air in the test tube cools and contracts. Hence, we conclude that the gases expand on heating and contract on cooling. Do one more activity to get an egg out of the bottle. For this, the materials required are a peeled hard-boiled egg, a plastic bottle with the opening slightly smaller than the diameter of the egg, a paper strip and a matchbox. Now we take the paper strip and burn its edges. Immediately we put the burning strip in the bottle. Fix the egg in the mouth of the bottle and wait for some time. We will observe that the egg gets pushed inside the bottle. This is because the burning paper causes the air molecules present inside the bottle to heat up. They move faster, due to which the air expands. This expanding air pushes the egg aside and escapes from the bottle. When the flame goes out, the air inside the bottle cools down and contracts, which makes space for new air molecules to come inside. With the pressure of the air coming inside, egg is also pushed inside the bottle. Now the egg is inside the bottle and we have to get it out. We tilt the bottle upside down and let the egg fall into the opening of the bottle mouth. While holding the bottle upside down, blow hard inside the bottle. We will observe that the egg pops out. This is because when we blow, the air molecules inside the bottle move faster and the volume of air gets increased, which creates a pressure to push the egg out. Hence, we conclude that the air expands on heating and contracts on cooling. Next effect of heat on matter is the change of state. On heating, the molecules of matter move rapidly and expand. Due to their continuous movement while heating, they change from one state to another. That is, solid changes to liquid or liquid changes to gas. This is known as change of state of matter. For example, ice, which is solid form of water, on heating changes to water, the liquid form. Water again on heating changes to steam, which is the gas form of water. Steam again on cooling changes to liquid water, and the liquid water on cooling changes back to ice, which is the solid form of water. During the change of state, there is usually exchange of heat between the substance and the environment. When heat is added to the substance, the process is called endothermic. For example, melting and vaporization are the endothermic process. When heat is released from the substance, then the process is called exothermic. For example, freezing and condensation are the exothermic processes. We will discuss the processes that occur during the change of state of matter. First, melting. It is the process in which a solid is converted into a liquid by absorbing heat at a constant temperature. The constant temperature at which the solid changes into the liquid is called its melting point. The melting point of pure ice is 0 degrees Celsius. Next change of state is vaporization. In this process, a liquid absorbs heat and changes into the gaseous state. There are two ways in which a liquid changes into the gaseous state. First, evaporation. It is the slow and gradual conversion of a liquid into its gaseous state at all temperature. It occurs only from the surface of the liquid and depends on the speed of wind and the surface area. Humidity of an area depends on the rate of evaporation. Drying of hair after washing, drying of floor after it is mopped are a few examples of evaporation. We do not require special heating for the evaporation process. Boiling. It is a process in which a liquid rapidly changes into its gaseous state at a constant temperature. The constant temperature at which the liquid boils is called the boiling point. The boiling point of alcohol is 78 degrees Celsius and pure water is 100 degrees Celsius. Boiling is not just a surface phenomenon, it takes place throughout the liquid. This process of change of state of matter is condensation, also called liquefaction. It is the process in which a substance changes from the gaseous state into its liquid state at a constant temperature. This phenomenon is also called liquefaction. Heat is released during this process. The constant temperature at which the substance in the gaseous state changes to the liquid state is called condensation point or liquefaction point. Change of state of matter is freezing. It is a process in which a liquid changes into its solid state at a constant temperature by releasing heat. The constant temperature at which the liquid changes into the solid state is known as freezing point. Change of state of matter is sublimation. There are some solids which on heating directly change into their gaseous state without going through the liquid state. Iodine, naphthalene, ammonium chloride are such examples. The process in which a solid directly changes to gaseous state on heating is called sublimation. The gaseous state of the substance obtained during sublimation is called the sublime. The substance formed when a gas changes back into its solid state is called sublimate. Next change of state of matter is solidification. It is the process in which a gas directly changes to the solid state on cooling. For example, gaseous carbon dioxide directly solidifies into dry ice. So we can summarize all the changes of states by the following graphical representation. The liquid changes to solid by freezing. The solid changes to liquid by melting. Gas changes to liquid by condensation and liquid changes to gas by evaporation. The gas changes to solid by solidification and solid changes to gas by sublimation. Now we will do an activity to show the interconversion of the states of matter and study their properties. The materials required for it are ice cubes, beaker, a container other than the beaker, a Bunsen burner, tripod stand and wire gauze. We take a beaker and keep ice cubes in it. We will observe that the shape of ice cubes does not change when we keep it in the beaker. This shows that ice cubes, that is solid, have a definite shape. They have also occupied a fixed space, that is, they have a definite volume. After some time, we will observe that the ice cubes undergo the process of melting and get converted into water, that is a liquid. Water then takes the shape of the beaker. Now we pour this water into another container. We will find that the shape of the water gets changed according to the shape of the container, but the volume of water does not change. Now we heat the water on a Bunsen burner. We will observe that water undergoes the process of boiling and gets converted into water vapor, that is gaseous form of water. The vapor gets scattered and occupy all the space available to them. Thus the shape and volume of vapor both get changed. So we can conclude that solids have a definite shape and definite volume. Liquids do not have a definite shape, but they have a definite volume. Gases neither have a definite shape nor a definite volume. Do one more activity to show the condensation of the water vapor. The materials required for it are a vessel containing water, a stove, a steel plate, and a pair of tongs. We keep the vessel containing water on the stove and heat it. As soon as we see the steam coming out of the water, use the tongs to hold the steel plate at a little height above the vessel against the steam. We observe that the steam condenses into water droplets on the inside of the plate. So we conclude that the steam condenses into water as soon as it comes in contact with the cooler portion of the plate. We do one more activity to show the sublimation of ammonium chloride. For this, the materials required are a funnel, a tripod stand, a china dish, cotton, ammonium chloride, and Bunsen burner. We take the china dish and put some ammonium chloride in it. Now place the china dish on the tripod stand and cover it with an inverted funnel. Close the opening of the funnel with cotton to prevent the ammonium chloride vapors from escaping into the atmosphere. Now we heat the china dish by using a burner. We observe that ammonium chloride changes into white vapors. We will observe that when the vapor come in contact with the cold inner walls of the funnel, it again gets solidified into ammonium chloride. Thus we can conclude that ammonium chloride undergoes sublimation on heating and solidification on cooling. Next effect of heat on matter is the chemical change. The chemical changes are the permanent changes in which new and different substances are formed. Heat is involved in the chemical changes in two ways. Either the heat is needed for the change to happen or it is released during the change. For example, when the vegetables are heated, they get cooked. Cooking of vegetables is an irreversible chemical change. Here, heat is necessary to facilitate this chemical change. Making of curd is another example of the chemical change. Put a spoonful of curd in a bowl containing lukewarm milk. Stir to remove the lumps and set it aside in a warm place. After some time, we notice that the milk has changed into curd. The curd which is formed cannot be converted back to milk. You must have seen your mothers making curd in the similar manner. So these are the chemical changes. Thank you.